All right, let's try a couple more examples. Let's do example 4.2.2. Assume that the integral from 1 to 14 of f of x plus 2g of x is 4. The integral from 1 to 14 of 3f of x minus g of x is minus 9. And the integral from I want to find the integral from minus 1 to 14 of f of x and the integral from minus 1 to 14 of g of x. All right, so just to simplify notation a bit, I'm going to call this A and I'm going to call this B. All right, so let's look at the two equations I will have. So if I have minus 1 to 14, f of x plus 2g of x, all right, so that's equal to 4. It's also equal, I can split it, and I could pull the constant out. So I get that 4 is A plus 2B. All right, let's look at this one. It's going to give me a different relationship. I get that minus 9 is equal to the integral from minus 1 to 14 of 3 f of x minus g of x dx. That's 3 times minus 1 to 14 of f of x dx minus the integral from minus 1 to 14 of g of x dx. So that's 3a minus b. All right, so I have my two equations here, and I need to solve for a and b. So now it becomes just algebra. I don't need fancy cal anymore. So you could isolate one. So out of this one, I guess that's what I'll do. Out of this one, you get that a is 4 minus 2b, and let's plug it into this one. So minus 9 equals 3 times 4 minus 2b minus b. So I get that that's equal to 12 minus 7b. So if I send this to the other side, I get minus 21 equals minus 7b, and so b is 3. Right? I'm going to plug that back into this. So that's 4 minus 2 times 3, and that's minus 2. So A is minus 2, and B is 3. All right, so here this is meant to be a 7. I'll fix it in your copy. Let's say I want to evaluate the integral from minus 1 to 7 of f of x dx, where f of x is this piecewise. Oh, sorry, I really forgot to change the bounds here. I'll change them. All right, so f of x is this piecewise. It's equal to this function from 0 to 1, this one from 1 to 5, and this one from 5 to 9. All right, so I'm going to split it because I have different functions anywhere. So anyway, so I'm going to put from 0 to 1, I'm going to put minus root of 1 minus x squared dx. I'm going to put from 1 to 5, 2x squared plus 4, and I'm going to put from 5 to 7, that function is now 9. All right, and I'm going to evaluate each one separately. All right, so let's start with the easiest one. This is just a constant, so I'm going to use that it's m times b minus a. M is 9, b is 7, a is 5, so I get 18. This one looks like the worst, but we've already computed it. This is what we did in example 4.1.9 part B. Let me show you just to make sure you agree with me. Ah, here it is. That's exactly the one we had here. In fact, I chose it, so it's 296 over 3. So this is 296 over 3, so let's not compute it again. And now this one, y is square root of 1 minus x squared. We've seen with a minus, so y squared is 1 minus x squared, and so I get x squared plus y squared equals 1. And so I have a curve that's part of the trig circle. It's part of the circle of radius 1, but it's the minus root, and so this is the graph I'm going to get. And so this is the region I'm considering. It's below the, oh, sorry, from 0 on. Let me redraw this. Same picture, same curve, but only from 0 to 1. So it's only this part that I'm looking at. And so the integral from 0 to 1 is going to be minus this area. And that's a fourth of a circle, so minus pi on 4. All right, so let's get back. The integral from 0 to 7 is equal to minus pi on 4 plus 296 over 3 plus 18. This is a horrible number. All right, so you could see we split it into the different parts. We took it from 0 to 1, from 1 to 5, and to 5 to 7, and that allowed us to look at this piecewise function and to integrate each part separately.